Hey there, this is going to be a video that takes us through the notes about Algorithms 2, and that is called pseudocode. So you could either watch the notes, you could watch me explain this. Tried to do this live in class and messed up my recording, so this is a makeup recording, and I'm going to try to demonstrate what I can. So hopefully this helps you understand this badge. So first of all, let's start with this word pseudocode. Like, what does that mean? The word pseudo, if you looked it up, it could mean something like an imitation or a fake. So the way to think about this is it's something that's kind of like code, but not really code at all. What it is meant to connotate is that when we want to write up plans for what we're going to do in coding, we don't want to sit around and worry about all the little details that go into code. Where do you put quotation marks? Where do you put parentheses? Where do you put, uh, any, depending on the language that you're learning, there could be all sorts of kind of funny things that you have to put in code. And when you want to solve the problem, you don't want to worry about that. You want to be focused on the problem itself. And so what you do, you can take the flowchart approach and mark down each step, put it into a shape depending on what you want that step to achieve, and then look at it as a visual. And for people who are visual learners, they might really enjoy that. But then sometimes you just want to say, I need to like write out kind of line by line what my code is going to do without worrying about getting it all technically correct. And so what we do when we do that is we use pseudocode. Now, I also will admit right up front that this is the kind of thing that teachers like to talk about because, English teachers like to talk about before you write your essay, write your outline so you know what you're going to say. And coding teachers, this is kind of the equivalent. We like to say, before you start your code, why don't you write out your plan of what you're going to do? And I admit sometimes it's easier to get right in the code and start thinking, but this is kind of a way to kind of get right into code and start thinking without worrying about all the details. So there's a definition. When you go to take the quiz, you'll want to know this definition. So take a little bit of time to look at it. I know it's kind of long. Pseudocode is a detailed yet readable description of what a computer program or algorithm must do, expressed in a natural language rather than in a programming language. This is not tied to any specific one programming language, so it might look a little bit like Python. That's partly because Python was actually engineered to look like what pseudocode might look like, tried to make it as kind of simple and clean as possible, and that's one of the goals of pseudocode, is to make it simple and clean. So they do share some similarities, which is why a lot of people like to begin their coding knowledge in Python. So if you look at the right-hand side, you might recognize the shapes from Algorithms 1, where if you wanted to use data, which would be input or output, you put them in a parallelogram. If you want to kind of show a loop, this is missing. I could see if I can add a little drawing on there because this is missing a few things on it that didn't show up for some reason. If the password does not, this is where we would say no, and this is where we would say yes. Because without these things, you could technically say that I failed Algorithms badge 1, and I've probably told some of you to fix these things on your algorithms, so I'll fix it on mine. Okay, so, this is a decision, and then the arrows show you what direction to go. So we're going to input the username. We're going to ask them if the password equals QWERTY. Now, we haven't even asked them for the password yet, so obviously it can't equal QWERTY. And so the answer is no. So then we input a password, and we go back and we ask again, is the password equal to QWERTY? So if they typed it in correctly, they'll get a yes on that, but if they didn't, they'll get a no, and we'll ask them again. So this is a loop, and the way that we represent loops in flowcharts is just by using the arrow and say, look, we're going back to here again and again and again. And we'll see how we do that in pseudocode in just a second. But yes, they got the password correct. They can go and be told that their access has been granted. So this is just a simple algorithm to check a password. In pseudocode, we take each box that happens in pseudocode and we think about how we would write that in kind of coding language, but not really worrying about the details. So this isn't how you would write it in coding language, but we try to make every step of pseudocode, if necessary, start with what we would call a keyword, so that we can see immediately what it is we're trying to do. So input username. So, hey, that's the exact same words that are up there. To show a loop, we kind of have to say, okay, we want to do a loop, and what is it that we're doing in our loop? We're waiting for them to type in QWERTY. Now, this is actually, because it's pseudocode, there's no rules for this kind of thing. This is not wrong, but there's also no need to do exclamation mark equals. That's how you would say not equals to in Python, and I don't need to worry about those details. So really what I could have just written right here is I would have just written not QWERTY. And now, if this was code, I would put quotation marks around QWERTY because it's a string. But again, that's the kind of thing I'm not supposed to worry about. So I should actually go to the eraser. And how do I erase? There we go. And not put those in because, again, if you do, is it wrong? No. But if you don't, it's not wrong either. While in a computer, if you tried to do it, without quotes, it wouldn't work. But for pseudocode, those kinds of details don't matter. So we've got ourselves a loop. We do show indents is how we show that some things are happening inside the loop. These are the things that we want to have happen inside a loop. And the reason why we do that, which looks a lot like Python, is just because it's a really handy way to show, hey, here's all the things I want to have happen in my loop. So in my loop, I'm going to input the password, which is this box right here. And then, again, you could do this different ways, but I just decided to ask an if statement. If the password is QWERTY, then we're going to output access granted. Again, I didn't actually even need, let's see if I can, no, I don't think I can erase things that are actually on the screen, but I didn't need those quote marks. I just put them there, but that would be extra. So this tells us what it is that we want to do. And then the loop will end when they have entered the correct password. So this is an example of pseudocode, and really looking at examples is the best way to kind of understand pseudocode. The rules. Now, I just said that the point of pseudocode is to make things nice and easy, which means there shouldn't be many rules. And so I've tried to keep these rules to a minimum. These rules are not technically, all people must do pseudocode this way. These rules are more like, here's how I think you should approach pseudocode in our class. And since I'm the teacher, I guess I had to make a few rules, right? Because that's what teachers do. But when you're doing it on your own, it's almost like what some people might call chicken scratch. You write down some ideas on a piece of paper, and does it have to follow exactly how I am telling you? No. But will this help you solve problems faster? I think so. And so this is the way I want you to approach how we're going to do this. Okay, so I guess there's a little, I feel bad putting in rules, but also I feel like there needs to be some rules. And also I did take this based on, again, some standard tests that exist in the computing world, and they actually use these rules. So I'm just using their rules. So the first thing is we put one statement per line, because when we do code, we do one code per line. So don't combine things together unless you know you can combine those things together in code as well. We're going to capitalize the keywords. So in the example you saw, I capitalized those things. Again, can it technically be wrong if you don't? No. No one's going to come by and tear up your pseudocode because you didn't. But to help you see what it is we're trying to do, I'm going to have you capitalize the keywords. We're going to indent our loops whenever, or if statements, things that happen inside a loop or an if statement, which we would call a selection. And the assignments where we want something to equal something, we're going to use the arrow. And that's to separate equals from assignment, because those are two kind of different things. You know, in math class, when we say x equals y plus 2, what you do is you're kind of got a balance, and you're trying to say, here's an equation and these two things are equal on both sides, and therefore I can kind of figure out what one side is based on what the other side is, and I want them to be equal. And so that's what we call a comparison equals. But in coding, when we say grade equals 96, it's actually, the computer interprets that as an action, almost like a plus sign, like I have to add these things together. But in this case, it's not add these things together. In this case, it's make grade equal to 96. It's not like check to see if they're equal, it's make it equal. And so we use an arrow to kind of represent that, because again, some languages deal with this by using, when you do an if statement, they use two equal signs instead of a single equal sign. So every language kind of has to come up with a way to handle the differences between those things, just because what computers do is computers put things, store things in variables, and we need a way to do that. Maybe I spent too long explaining all this. So what are the keywords that we can use? Well, these are really the key keywords, and you can solve all the problems I've given you using these keywords. Like if you want to input something, say input. If you want to print something in code, you just say output. If you want to make something run again and again, use the word loop. And if you want to compare something and find out if something is equal to something, use the word if. And if you go real quick back to here, basically what we want to do is the if statement. You can almost think of the yes as being the if statement, if this equals this. And then the no would be the else statement. No, they didn't do something, so that's what the word no or else should be. So we don't use yes and no in pseudocode, we use if and else. So let's look at how that works. And this is what I was talking about with the yes or no. Let's say you have a bank, and the bank wants to set different interest rates depending on how much money people save in the bank. It's a very common thing that they do in banking. You save a lot of money, you get more interest because they can use your money to make money themselves. So we just have a simple algorithm that says, well, is the amount less than 1,000? And if the answer is yes, it's less than 1,000, their interest rate gets set to be 0.06 or 6%. And if the amount is greater than 1,000, it would say no, and the interest rate gets set to be 10%, 0.10. And then we'll write that in pseudocode with an if-else instead of yes-no, right? So if the amount is less than 1,000. So we take the diamond and we turn that into an if statement. And if the answer is yes, it does the thing that's indented here. And instead of an equal sign, we show it with the arrow. So interest rate gets set to 0.06. And if the answer was no, then the interest rate would get set to 0.10. And so we use the word else. And so this would be an if-then statement, or an if statement in Python, how it gets shown in pseudocode. So now let's take a quick look at, and let me see if I can type in here, how would you convert some algorithms that you see in flowchart form to pseudocode form. And so you can kind of do this along with me or try to come up with an answer as we go. And so the first thing is, well, we don't have to put that in pseudocode. So count equals 0. So what did I say the rule was for making count set to something? We should put the arrow. So maybe I'll do an arrow here, and then, whoa, and then I'll do a text box here, so I can just type 0. I guess I could have drawn a 0, right? That shouldn't have been too hard. And then this, first of all, you kind of have to ask yourself, what is this doing? So you might want to follow through real quick. It's asking a question, is count less than 10? And now, because I see this arrow here, I know that it's a loop. And so that's one of the keys, is if it was a diamond with nothing coming back to it, it would be an if statement. But if I see like a loop coming in, an arrow coming in like that, I know there's a loop. So that's why I put the word loop here. So this is saying, is the count less than 10? If it's not less than 10, we're going to write the end and we're going to stop. And if it is less than 10, we're going to just add 1 to it, and then we're going to write it or output it out. So loop while, so we just have to write the test right here. So, well, why is it not letting me type? Because I'm not in the text box. There we go. Loop while count less than 10. So I'm just going to put that, it's the same test. It's like I'm just taking the box here and putting it over here. If you just said loop count less than 10 and didn't put the word while in there, I'd understand it too. You just kind of use the word while to make it a little bit more Englishy. And by coincidence, that happens to be the word we use in Python to make loops, but that's not why we do it. It just makes sense when we say, well, loop this while the count is less than 10. So what do we do if the count's less than 10? We're going to add 1 to the count. And so what would that look like? We want count to go up by 1. This is just a little tricky thing, and I wanted to explain it in a little bit more detail. Why we do this, because this happens a lot in coding, is that we say a variable equals itself plus some new amount. And so real quick, I just wanted to show you, if I typed in, I want to show you an empty cardboard box. And I'm going to put that cardboard box over here. Hopefully it's not too much in our way. Think of what I like to think of variables. You know, it's a memory location in the computer that you basically have said, hey, memory location, why don't you make yourself like a little box I can store things in, and I'm going to write on it, you know how like if you're moving or something, you might write kitchen for your kitchen stuff. So I'm writing on this box count because I want to store something in count. And so then it's like, cool, I'm going to store the number 0 in here. And so it becomes a 0 at the beginning. And then what happens when the computer is if you say something like count equals count plus 1, is it says, okay, what's currently, it does like the right side of the equation first is the way to think about this. What's currently count? Count is 0. So it's like, I'm going to take that out of the box and look at it. And I'm going to look at this 0. And what am I going to do with it? Oh, I'm going to add 1 to it. So it like, well, I want to draw one more thing. So it's like, let's take what's out of the box, kind of place it on the table because we're dealing with it. So the 0 comes over here. And then we add 1 to it. So it's like, oh, cool, here's what I want to do. I want to add 1 to you. And then it's like, well, where do you want me to store that? And I say, hey, I want you to store that back in the same box because I don't want to create a new box, like get a new box out every time. So the computer's like, cool. Oops. Well, I was worried that would happen, but imagine there's a box right there. And so it says, cool, I'm going to store this new thing in the same box because I like to recycle my boxes, right? So it puts the 1 in there. And then the next time it takes the 1 out, puts it on the table and adds 1 to it, and then puts the 2 in here. And so that's what this is doing. It's like reusing the same box to store information. And we do that a lot in code. And you'll see that a lot, and it just helps to understand that concept. So now, what do we do with count? Well, the next little line here is write count. So what do we put for what's the keyword for writing something or printing something? It's the word output. So I'm gonna, well, I put it in not the greatest place, but you know, output the count, and then, hey, what happens in the no? So now we've like taken care of all the yeses. So what happens if it's not less than 10? We're going to write the end. So here it says, well, you're going to do output. What is that output going to be? That output is going to be the words the end. And so that's how you think about creating these. And the reason I went through this really slowly and trying to explain it to you is because you are going to have to, in the examples I give you, create a loop. You're going to have to do 3 out of 5 problems that I'm going to give you. And those problems are mathematically based. And at least one of the problems, you can get away with not doing loops for, I think, the first 2 problems, or maybe it's 1 and 3. But problems 2, 4, and 5 will require some sort of looping feature. So go back to, if you have to do a loop, go back to here. Every loop is basically in the problems I give you is going to involve something like these two lines of code where you want to say, I want to loop something 10 times. Okay, make a variable, call it whatever you want, call it count, call it loops, call it, whatever, X, and then say, keep going 10 times and add something in that loop every single time. So these two lines are really key for you. Do you have to print that loop out every time, output it? No, not necessarily. So this is what I wanted to do with this one, but it's not what you always have to do with a loop. But these two lines you definitely would use. So let me just show you the examples which, oh no, actually, first let me tell you why this is important. No, I've lost my train of thought. Sorry, now I have a really bad video, but I'm too far into it now. So here's some examples, and we don't have to go through and explain every single one. A few tips that you need to understand. Number one, these examples are asking you to think through math problems without actually solving the math problems, which means, like, if I say find the average of 10 numbers, I don't want you to create 10 numbers and tell me the average was, 2. I want you to show me the process that the computer would have to use to take 10 numbers and find the average of them. We don't know the numbers. You don't have to make up numbers. You just make up variables to store the numbers, okay? So if I say, find the great common denominator for two numbers, you don't have to say, like, a equals 10. That's one of the numbers I'm going to use. No, you just say, hey, user, find out what A is. Hey, user, find out what B is. And then do things with them. So, again, here, Celsius and Fahrenheit. I know I could ask you to find how Celsius converts to Fahrenheit. I mean, like, to say, hey, it's 0 Celsius out. What's the Fahrenheit? And then you could tell me. But how do we tell the computer to do that? And that's what gets really interesting about algorithms. Every single thing that happens on a computer has to be boiled down into basically math. All the computer has running through it are, these electrical signals that are zeros and ones. And so everything you see on a computer, whether it's sound, whether it's, cat videos, whether it's games, somehow it all boils down to zeros and ones that can be added and subtracted from each other. And that's all it is. And so when you play Pac-Man and you have 4 ghosts running around the screen, somehow they were able to say, here's the algorithm for the paths that these ghosts should follow. And one ghost tries to chase Pac-Man. One ghost knows enough to try to predict where Pac-Man is going and get there before he can. And every ghost has its own, like, mathematical system it uses to make its way around the maze. And then when you're playing, like, a racing game, they've come up with mathematical systems to show you the difference between racing on pavement and racing on dirt. And so the algorithms that they had to come up with so that it feels different to you, including, your rumble pack and when to make it rumble and things like that. So all of these things happen because of math. And so I'm going to ask you to do some math problems here and try to solve, how does the computer think about solving a math problem? Not solve a math problem. How does a computer think about solving a math problem? So again, here's an example if you have to do an if statement. We have temperature, we have scale. Do we even use scale? No, I don't think we need that in there. Maybe I see. See, I would let them actually choose that they want to do it with Fahrenheit. So if they choose Fahrenheit as their thing, oh, I see, because I wanted to convert, I can't even remember my own examples, sorry. Convert between Celsius and Fahrenheit or Fahrenheit and Celsius. So if they say they're Fahrenheit, we do the math to find out what Celsius is, and we tell them. If they say something other than Fahrenheit, we'll get the temperature as if it was Celsius, and we'll output the new Fahrenheit temperature. So it doesn't say yes, no, it doesn't say numbers, it just says, there's numbers in the math, but it doesn't say exactly what temperature we're dealing with, it just says here's the process the computer would use to do that. Again, this example down here is to help you with a loop. Notice I set something called current. I'm trying to add up all the numbers between I'm going to find the sum of all numbers of 3 or 5. That doesn't, all numbers divisible by 3 or 5. I don't know what I'm talking about anymore. So what's the current number we want to look at? We put that into a loop, and down here we make the current one go up. So it looks at the number 1 and says, is that number divisible by 3 or 5? If so, add it. If that number is not divisible by 3 or 5, skip it and add 1 to current. So now we're looking at the number 2 and saying, is 2 divisible by 3 or 5? And then 3 is divisible by 3 or 5. And so this one has some hints that can be used in a lot of the examples that I gave you. So if you kind of step back and look at this one, it might help you find some solutions. So that's what pseudocode is all about. It can be a little bit tricky. The concepts of pseudocode aren't tricky, but I will admit the first time you go to try to actually think like a computer and say, how do I mathematically do these things, that can be a little bit tricky. So good luck, but I hope that this long explanation is not too long, but actually helps.